Hi everyone, and welcome to our tech sessions. Today we will be working in the project section of the ecosystem.AI Workbench. We'll be looking at a use case, its prediction story, how it's mapped onto the ML canvas. And then from there, we'll bring everything together into the Workbench to demonstrate how a project is set up, configured, and how it's kind of prepared for deployment. And Ramsey is going to be taking us through that today. So the use case we are looking at is one we discussed a few weeks ago in one of our meetups, which was a credit card activation use case. So the idea behind that is, for a lot of banks, inactivated credit cards is a major problem. So they have a whole range of customers, a certain number of those customers apply for credit cards, and then a certain percentage of those customers who applied for their credit cards and received them never activate them. That was quite a problem for a bank in terms of cost and management and all of that. And the way banks would traditionally try and engage and encourage people to activate their credit cards was through generic messaging or rewards to kind of prompt action and drive a customer to activate their card. But as we unpacked, that is not particularly effective. So we looked at a new approach, which was this behavioral-based approach using our spend personality. Now we want to see how that use case would be built out into the project section and what are the technical requirements. To begin, I wanted to share the overall prediction story. We spoke about that a few weeks ago as one of the first steps on the ML canvas. Essentially, the idea is to predict which activation message to send to a customer. You predict that from their spend personality, which is determined by their transactional data. And then you do that to get them to activate their credit cards. So that's the prediction story. Ramsey, if you can share your screen and we'll go straight into kind of the project section.
That's perfect. But just before that, just give everybody a refresher on what the ML canvas looks like. So this is the machine learning canvas set up for the use case of credit card activations. There's a lot of information in here, but we're going to slowly work through them and set up our project as we require. You can kind of loosely follow the numbers, but the key thing is you're going to start and see what our value proposition was. We basically want to determine what are the most efficient messages to send to people to get them to activate their credit cards. Then we have important steps we have to look at. Our data, where we get it from, and how to enrich and transform it until we get it into the format that we can use for modeling. Then we're going to start looking at, well, 2 and 4 are part and parcel. Then we have our dot 3 here. This is where we can decide what machine learning we want to use, given the data that we have. This is kind of all like cyclical thinking, because data determines what you can do, determines what models you want to use at this point. And then finally, we get to 5, where we want to start thinking about how do you want to track our outcome of the model, like what do we determine as success and how successful was that model. Yeah, kind of 6, once again, it's just a live monitoring event. This is after the model is deployed. How do you make sure that your models aren't falling over, performing worse, or degrading? First, we have to decide what do we want to call our project. So our project is a kind of main container for a use case. This is where you group all the pieces together under one banner, so you know that everything under this project is going to be to do with a particular use case. So let's create our use case. We know this is going to be around credit card activation, so we can call our project credit card activation. There's a lot of metadata you can fill in here. This will be mostly just used for internal tracking and referencing.
This is where different roles within the business can look and see whether they are all aligned and all on the same page about what the purpose of the project is.
Yeah, so that's kind of what you're looking at your logs, your description configuration files. This description is where you describe just what is going on here, what the purpose is, who it's for. It's a way and a place for people to get an overview of what is happening in your use case, what teams are assigned to, things like that. You can just look into some kind of date. When you think these things are for, you can add people associated with this, write some kind of description about this. So this is a configuration that's meant more configuration around what steps you have to follow to kind of implement this. So it's just a description, a technical description. I'm not going to write too much in here. probably not going to bother filling the rest of these fields. And then you have your module metadata. So at the end of the day, when you have your project all set up and configured, you can export and share this across different users very easily and quickly. All the data here is just metadata associated with that module. There's a way for you to track and make sure that you are working with the right things like categories, links to documentation, images, versioning, all kinds of things like this. Then once you get this JSON settings and dashboard detail stuff, this is just basically showing what you have here, kind of previewing it in the dashboard, and the JSON settings is just all this information in the JSON file. So if you want to use that, roughly you can. And then you have the part where you attach things to your projects. Currently, we have nothing attached to this at all, because all of these fields are empty. We will be filling this up as we go along, building this project. Let's just save this for now. We have our placeholder here. If you go back to projects, you should find our project. I just have to refresh the page. Then we have our script for activation. Usually they get sent to the back, but in this case it didn't get sent to the back. So we have our project, it's set up. Perfect. Now we need to start filling in things. The first thing I want to do is have some data to work with. You can't have any kind of machine learning project without data. There are multiple ways to get data in your system. I'm just going to keep this tab open because we can refer back to this many times. We're going to feature engineering first. This is our collection of data that we have set up in the environment. Because we are kind of just demonstrating this case, I already have some data pre-set up for us, so I'm not going to generate or import data at this point, but I'll just show you the different steps. The most practical way to get data in is using Presto. Presto is a data virtualization platform or a wrapper that makes it easy for you to connect to any kind of data store, data source, database out there using a standardized query language. So you can see there's some existing ones already that do something. This one just does select, but you can set up your own queries to get the data that you want from the sources that you want into the ecosystem. Underlying, we use MongoDB to house data for a lot of speed requirements to get the kind of hyper fast runtimes to work properly in sub-second recommendation times. And we do require document-based stores natively support Mongo, but you can also set up Cassandra connectors and generic connectors. Like I mentioned before, there are speed concerns around that, so we prefer not to use it if possible. Alternatively, if you also want to not use, for security reasons or whatnot, just for getting your start quickly, you can also inject raw files and ingest raw files. Here, that's easily done by just going in, like creating a database, selecting one, like you can ingest in collection, you can choose any files you already uploaded to the system and just ingest it. Usually come with either be a CSV file or a JSON file. You can generate a collection from that. But we already have our data set up here. Since we're doing credit card activation stuff, we want to have information about our customers and their bank transactions. So we have a bunch of data around here about our customers. Now we can go back to our list. We have our data source sorted out as data sorted in time. We have transaction data, transaction amount, some MCC codes, payment type, and customer ID as well. Customer data. This data tells us that we need the MCC data, this credit card, company-specific data that determines the category of the transaction. So well-established credit card ID that they use to determine the category of spend. We have our data sources set up. Now we're going to get to our data enrichment. So there are a lot of steps you can do here to create your features that you require for your modeling. The majority of it is going to depend on what data you have available and what your goal is finally. But the core thing we have noted here is our variable enrichment and our time series enrichment. We have a lot of enrichment options baked into the system. So if we come in here to our transactions, create the enrich features, you see we have a lot of options you can use here. Obviously, there are going to be times when you are going to require some very specific or customized enrichment. If that's the case, then you will need to use the low-code environment and not the no-code environment. Currently, we're just demonstrating the no-code environment. But we have our data enrich. You can just pick a data enrich there, opens up a new window, do some enrichment. Sometimes it takes time depending on the complexity of the enrichment. Since we already have the data enriched, I'm not going to run this right now. Then we're also talking here about the behavior enrichment, basically giving us a spend personality. You can potentially build your own spend personality if you so. Like we already have a spend personality model set up in our environment that requires certain types of data, particularly time-based add stuff and enriched. If we now go to our bank transaction personality, you can see we have our customers from the transaction list scored based on their personalities. We basically have 4 personality types and 2 traits, introvert and extrovert. Your personality is experiential, extrovert, intentional, and industrious. Depending on the model, they will score each of these fields different values, and then the best one will be given as the personality trait for this user, but you can see the individual scores here, so if you're interested. We have that data now, we have the personality data, so go back here, and time series enrichment data. So time series enrichment data is just basically taking a single datetime field and just getting all the information out of it. It will give you things like, is it after hours? Is it on a holiday? Is it the weekend? What's the day of the week? What's the week of the month? What's the year? It just takes like a well-compressed piece of datetime information and just explodes it up into all the possible features that you would potentially want to use for your modeling use. Okay, so we have our data enriched. Now we want to make sure that this data that we just generated is attached to our project. So we can go back to our projects page, onto our collection field over here, and attach these things. Now that this was set under credit card activation, and we have bank customer, let's add that. Let's add the personality data, let's add transactions, add them for now. So now we have our data. We know that these data is associated with this particular use case of credit card activation.
Under project elements, where you update, this is not how it gets added to the actual platform. It's more just to create a connection so you can keep track of what is being added to the project.
The data is already ingested into the system. What I just did now is to make a soft link saying that this data is associated with this project. It's not required for functionality, but if you want to export your module and can easily share it with other users, this is the way a project knows. These are all the elements associated with the project. I need to extract them, compress them, push them into a shareable file. Cool. Okay, so we have our data set up and we have it attached to our project. Perfect. So the next thing we want to do is set up our feature store. We now have our data in the format that we want, but we still need to set up our feature store. Actually, before we get to the feature store, we need to think about what models we want to generate. We can potentially build either static models or dynamic models. Static models are standard history-based models where you just have a large chunk of historical data. Use your XGBoost and your GBM models to predict the future, essentially, predict what's going to happen if certain elements are fed into it. Alternatively, we have our dynamic recommenders, which allows us to build models given a cold start. So if we have no data at the point that you can also ingest history into it. Static model, you have large amounts of data, lots of different features that you're interested in. Depending on the scope it is to train, can take multiple hours, multiple days, multiple weeks, depending on the scale. The key component is that it's slow to refactor. So each time you get new data, you have to retrain. It's going to take X amount of time for your new model to be up. Where dynamic recommenders are more set around being quick and fast to change. So essentially, every time a new score is generated, a new prediction is made, or when the prediction is successfully accepted, depending on this use case, it will be a credit card is activated. Every time one of those data points comes in, the model is dynamically updated and retrained. So this is useful in multiple ways. First is that you don't need training data because essentially in the beginning it just does a random guesses, but then as information comes in, it will very quickly start converging on answers that people like. And then secondly, you're very quick to adjust to unusual cases in your journey. So if something unusual happens on a particular day, like a big sporting event, like the Rugby World Cup came to your city and drastically change the spending behavior of your customers, or in this case, the credit card activation behavior of your customers, you can quickly adjust to that change in behavior. So this is all depends, like how quickly you converge, all depends on the hyperparameters of the dynamic recommenders. But since this is not a modeling session, I'm not going to focus too much on that. Just wanted to mention the two differences there. And why that's important is that for the dynamic models, you're not going to be setting up feature stores as such. They have their own style of feature stores called option stores. But due to the use case that we're setting up here, we are not going to be building a static model. We're building a dynamic model because we want to generate customized messages for users. Since we have no historical training data on what different types of messages work well with customers, we just know that certain customers, certain transaction histories, and activate a credit card at some point. So next up, we're going to kind of skip this feature section for now. Next, we're going to think about our ML task. We want to predict our customers' messaging based on their personality type. So essentially going to be, determine or hypothesize that customers that fall into certain personality types like being communicated with differently. So we know we hypothesize that industrial spenders will like more to the point messaging saying, you know, if you have this credit card activated right now, you can buy the toiletries that you need for this week. Where if you have your more experiential spenders, then you might want to entice them by saying, hey, you see this new fancy gadget that just came out this week, get this credit card so you can buy it now and find this new exciting thing. So that's our hypothesis. We need to think about how do we want to build this dynamic recommender. So first off, we want to go to, so we can either start looking at this on the deployment side or the dynamic recommender side, but I'm going to go to the dynamic model side first. So come over here, you just want to set up a new model. You can just come in here, give it some name. Let's just call it the same things that we know we're talking about. Attach our training store over here. So this training store is basically our feature store. It looks a bit different in the feature stores for a static model, but this essentially, I'm just going to attach a file that also pre-generated that is going to be listing all the facts that we are interested in. In this case, it's just going to be the message types that we are sending out and the personality type. So in this case, we use files called messages. I'm going to be speeding through this since it's not the focus of this. I'm just going to set up something that roughly works. We're just picking a type of engagement, the algorithm we want to use, setting up some hyperparameters for this. So we get a very generic answers here that just does something. And then we attach some, tell it which of these. So I got the personality message. Then we want to go the message for Gmail first. These are all the different messages for different personality types. It's not any specific messages. It says message 1, 2, 3. In a proper case, you would have some kind of message replaced here saying, hi, X, do you want to buy this thing? We use personality as our contextual variables and group them in separate personalities. It's interesting. Something has happened to the generate button down here. I'm not sure if it's moved somewhere. Maybe it's not important for this meeting. We'll basically just set this up, and we now have a functional dynamic recommender. We need to set up a deployment for it. I don't think the deployment is actually set up, but it's part of the whole data source ML task building models that we want to use. That's the key point where you are setting up the deployment for the runtime. The runtime is the key working portion of the environment. It's a very small, lightweight, containerized environment that takes all the information that you set up around the data to use, what algorithms to use, how to target, which kind of outputs to give, and takes in information about the customer you want to score against and gives you the answer. So to set up those configurations, we need to go to deployments, project deployments. We're going to find our credit card activation project that we set up. Currently, we have no deployments associated with this. We're going to create a new deployment. We can give this a name. This is going to be our message recommender. Let's just call it that. Recommend a message. Easy. This is also has a lot of settings that we need to set up. The key things for a dynamic recommender that we require to get this to work is going to be our parameters from data source. So we need to link our customer data, the personality data that we've generated before, add in new knowledge. This is so we can connect the dynamic recommender. We need to add in plugins, which is an additional kind of code line that can differentiate between different use cases. I don't want to use a static model, a network selector, dynamic recommender, kind of the place where you can select that. So we have our free core groups of configurations that we want to set up. You can just create it for now. You see a lot of this is craft stuff that we're not interested right now. This is where you can set up your build paths if you want to set up a build server for these. And then I've got database settings. This is all the settings that the runtime requires to connect to the root data. So all the customer data and the historical scoring data. In this case, historical, it could be no data, but as soon as you start scoring against the data is going to be generated. All the logs around which customers scored, were recommended which products, and which products were taking up. In this case, the messages, which messages led to credit card activations. And then target the runtime where the URL is for the runtime that we want to deploy this to. So this is depending on how your system is set up, you can just point it to the right place. That was our database settings. Now we come to our custom settings. Once again, the JSON settings are just like in the project, just all of this information shown as a JSON file. This is not that important for us right now. And first of the custom settings that we set up now is our parameters from data source. So this is our customer lookup. This is all information we require to recommend the work. We're just going to look up personality fields that we generated before. We're going to create card activations, pick our bank transaction personality. Then we can click the validate here. It will basically just check that that thing exists and give us all of the associated fields in here. You just take out that ID one as that underscore ID is an internal Mongo artifact that we're not going to use. We can pass along all of these fields, but only the ones we selected for our dynamic recommender are actually going to work. But we need to make sure that the ones we use in our dynamic recommender are actually in here. But it doesn't matter if you pass extraneous things along. And then we just need to select our lookup key. This is the main key when a customer is scored. So when we call the recommender, we say customer 101 comes in and does something and asks for a recommendation. In this case, which message is sent to customer 101. That will then look up all the associated information about that customer and pass it along to the model. So we have this set up and we need to specify the data type of that customer ID. In this case, it's going to be a string. You can type in anything, but standard is just to use 1, 2, 3. And we can also set up default lookups. This is only required if you are expecting users to come in that you don't know the ID about. If you do know the IDs, if you're sure you're going to be only predicting messages for customers to have information about, you can leave this section blank for now. Okay, so we have our parameter lookup set up. Then come to our plugins. Plugins are pretty straightforward. We're just going to be selecting for both our pre-score and our post-score. We're just going to use the dynamic stuff because they are setting up a dynamic recommender. There are 3 different ones. This is also editable. You can do very specific custom logic in here if you want to. I'm not going to talk too much about that. And then we have our new knowledge. So this is where we link our dynamic recommender that we set up before. Just click that one there. And then we have 2 additional settings up here for the multi-unbounded section. This is just to add some randomness, some variability to the output, which is useful in making sure that the model doesn't get stuck in local optimums, so it doesn't find an answer that's good, but not like the best. Especially if your convergence is like set very high on the dynamic recommender, you can get very heavy into a certain answer, thinking a certain answer is good, but then as time changes or as conditions change, there might be new, better answers coming out. And this epsilon value is basically just a way of deciding how quickly your model will pick up those changes by recommending random things. So this currently is 10%, so every 10% of the time, it's just going to give a random offer instead of a predicted one. So it kind of tests as it goes. So as the system runs, it will sometimes test to see if any new answers are important or not. And then we also have our cache duration. This is useful for when you want to be able to make sure that the customer coming in this case, we're sending out messages. If the customers are coming to you to get their recommendations, it's a way of just making sure the recommendation that was given stays the same for a set period of time. So you could have like a 1-day cache duration, and then if that cache duration has expired, when the customer comes in new, it will get a recommendation for the rest of the day. It will just show that same recommendation without scoring against the model. In this case, we don't care about it. We can just leave it at 0. We can update this for now. Now we have our first, if you go over here, deployment set up. Just probably need to refresh that. Deployment is set up there. I forgot with the dynamic recommender. We just probably want to set that in as well. Yes, Jess, I see you have a question.
I was thinking about the importance of versioning when working on a project, right? You don't necessarily want to be running the same model constantly for months and months on end. You do want to learn something a little bit from what you've created and have that feedback in place, and then maybe update. So is the versioning something that you would separate by project level, or would you have multiple versions that fit within a project space?
So we do the versioning on deployment levels. Deployment is the core worker configuration. So you can see over here, we had a version set up over here. You can now easily create a copy of this by just changing our version number. If you go back to, I think you now have two identical deployment recommendations or recommenders here, one being version 1, one being version 2. And now you can just come into the new one, make changes, and just push it as required. You can also on project level do versioning, but it depends essentially on what you want to do. So if you have like a project that is set up and works the way you want, and you want to now do something quite large scale differently, then you might want to version your project. But if you are looking at a very specific component of your project, just one model that you maybe just try a different algorithm, a different approach to see if you can perhaps make the uplift slightly better, then you would come to the deployment level and iterate on the versions there.
Okay, and if it's, I'm not entirely sure how the versioning would be split out in this case, but I'm thinking about this credit card activations case, right? What Madison spoke about when she presented it was to present messages to customers based on their spend personalities. And then one of the things that was talked about was having this booster element where you can recommend rewards. So on the one hand, you've got your messages that get sent out, and on the other hand, to bolster what the activation process looks like, you can use rewards to further entice. Would that then be multiple versions of the same idea in the same project, or would you have a project for the card activation messages and then a new project for the rewards?
Well, you can't attach projects to projects, but I think it comes down to how you want to structure your campaigns or your projects. I can see both being done. I personally would do it on deployment level. My project is credit card activations. There are multiple ways to activate a credit card, multiple strategies. One of them is sending particular messages. That could be our first recommender, our version 1 recommender. And our second one, this new approach is going to require 2 recommendations potentially, depending on what rewards you want to do. The second one would be a message recommender with a reward recommender, and then potentially a network selector to join these 2 different recommendations together. Also depends on at what point you actually connect these things, because it also got to be on the front end that it connects the message with the reward. So it depends. It's a bit of a cop-out answer, but it depends.
No, that's perfect. That's exactly what I was looking for. It makes total sense. Thank you.
We just have a lot of tools in place that you can use. We have our preferred way of using it, but also now working with a lot of clients, kind of helping them set up their initial POCs. I see them using it in different ways that I wouldn't do, but it's obviously due to corporate culture or just their own personal preference. They like to organize and sort their data and projects in slightly different ways. And that's all. It's just a tool at the end of the day. Do what works. I was busy setting up the dynamic interactions. Now we can, in the use case here, we have set up basically our decisions, our ML tasks, our value proposition, all these. Didn't pull the model, but we pulled a dynamic recommender. So now we have the non-workbench stuff. It's around how you want to track the success of these things. The first thing you want to consider is testing that your different models and things work. We have kind of multiple stuff you can do around that. So the first one is to set up an API tester that can score against your model and make sure it is returning values that are sensible. That lives under laboratory. You have to manage APIs, create a new one, and then point it to the runtime, which is going to be the same as whatever you set up for your project deployment. So in this case, we can see it is coming here, copy it, it's already the same default first place for our one. You can save it, that's our first step. And then you have multiple calls you can do to runtime. You can do essentially invocations of offer recommenders are the same, it's just slightly different formats. I think originally it was the invocations endpoint required for the web-based infrastructure, so your AWSs and your Google Cloud and all those things. But essentially the offer recommendation and the invocations do the same thing. The response is just a part where you are saying that the offer was accepted. So you can come in here, set some things up. Look up over here, some of our customer numbers. So this is something that we need to know from our customer list. We can just come look in our feature engineering. So I don't know off the top of my head what any customer numbers are in this data. Just find it quickly. Give me a customer number there. Just add in a customer number there. Change our number of responses. In this case, we only really want to get one response. We don't want a list of responses that are ranked. We can just leave that blank. Specify users, that's all. So now we have our API set up. Perfect. Let's, before you forget, come back over here and just add that to our list of things that we want to add to our project. So it should search in there. I've got to refresh this first. Add that to the project. Now we have another element attached to our project.
I don't want to derail the process or send you off on another tangent, but I did want to ask about whether it would be possible for us to see any of the other interfaces that we could use in light of the conversations we've been having recently about the no-code versus the low-code environments. Could you give us a quick view of how and to what capacity you could actually build out a project in a different interface, maybe something that's a little less no-code?
I think that's also important to note is that this kind of front-end no-code interface is going to be your first port of call. This is where you come to set up your proof of concept and figure out all the details. Once you have that done and you want to start productionizing this thing at large scale, it's usually easier to do it programmatically, doing it in a notebook environment where you are able to automate a lot of these steps. Might seem a bit counterintuitive, but in one case we had a multi-model project where we built a model for each offer. Let's say there was an option store of 100 different offers. So instead of building one recommender, one model that will tell you what is the best model, we did a one encoding model for each offer. We're saying that for offer A, there's a model that will just tell you how likely is this customer to take up offer A. And then we had 100 of them. And you could theoretically go in here and do what I just did 100 times, but that seems like a big waste of time, especially since the changes between the models are going to be usually quite small. So it's easier then to automate it and just, once you understand the structure, you can replicate that in an automated process. Let me just show you quickly. If you come to our dashboards, on the first port of call, you can come to new Jupyter Notebooks. There's a bunch of stuff up already. I'm just going to close all of this. Then you have our notebooks by default come with a kind of a bunch of documentation around it. It's going to show you how to do a lot of different things. So let's just pick one, dynamic. Yeah, I'll get started with recommenders. So here's one that basically shows you the majority of what I did now. It just shows you how to set up and deploy a dynamic recommender, given the project stuff. It shows you in text out and all the stuff. What's important to note for those not aware, our server is completely API driven. Anything you can do through the Workbench, you can do through the back end. They all just call the same endpoints, so it's just knowing how to configure it. The hard part through the notebooks is setting up your big configurations, like setting up a model of some kind. And knowing all the fields to put in here is sometimes not going to be that obvious, but that's where the front end is nice. If you just have your first case set up, you can just look up all of this information and then just replace the fields and things that are required. I think that's probably fine for now.
Thank you.
What was I busy doing? So another of the steps you can do to kind of track the functionality of your project is simulations. So let's go have a look at simulations, also under laboratory. So simulations is essentially going to be a way for us just to basically use the API endpoint call that we generated and just do it a lot of times. So you can do like load testing, stress testing. You can do just making sure that the model is converging sensibly. It's not like going off on a tangent for some good reasons. So just like a sense check on your system to make sure that everything is good. You can give some descriptions to it. Okay, yeah, attach it to a project. In this case, this was credit card activation. You can attach this to a particular recommender and a particular version for that. So you can save that and create a run. For each run, you can set up different runs for each simulation. Let's call this 1x for the particular. The most basic of default things you can set up is just X amount of scores being generated, recommendations being made, and then just let a certain amount of customers accept that. In this case, we're going to do 1,000 ones, and 10% of them are going to accept it. You can also get a bit more advanced with it. This is not the purpose of this, not to set up a simulation. There's basically a set up custom take-up rates to make sure that you have a more realistic view of simulation, not just that the 10% of people accept it. So you can then set up per customer or per category take-up rates. You can also do some standard deviation stuff where you can have the take-up rates and the scoring rates differ a bit over time to simulate more natural customer interaction. Yeah, you can save that. We can come back to our project here and go to simulations, attach that. This was created to refresh this again. Attach that. That basically covers all the steps. Unfortunately, there was some issue with the data. I wanted to just show actual working example, but I just kind of show the steps now and how to attach all of these things to the projects and what would be the general process that you would follow. Once you get to the step, you would run the simulations, run the endpoints, and then you can either look at the results in Grafana or directly look at them in the Workbench. I'm just going to take one that I know was functional earlier. You can come over here, look at analytics. You can have a lot of
just had to transfer, and it looks like that me server does not have the default security set up. That means that the generate functionality.
Yeah, I couldn't generate it, but I was very
the role configurations, that might be worthwhile to do a session at some point, just to show where all the roles get set up. People can change their roles. If you go to manage roles and you go to admin, there are different types, so part of the product can be configured. So he's just done it now. I think just maybe leave it as it is. He's just setting it up because you can just go add, and when you add, there's a role permission that can be added with a name.
Yeah.
Parts. So it works the same as a cloud-based AIM configuration.
So you basically set up roles over here, and then when you have your different users, you can.
Yeah, if you go back to that generate form, it should be enabled.
Back into actions. Variables. There it is. It's back again. You can generate this. And all the different things over here. Everything is blank. So theoretically, unless I did any mistakes now, we can just push our deployment. Just switch this. Just push this. I think I made a mistake over here. This is actually a numeric, this lookup key. Change that quickly. And push it again. Process I'm doing now is actually sending all this configuration, all the models and things that we built now, is sending it to the runtime and preparing it to be able to score against it. So the push is now complete. So unless I made a mistake, we should be able to go to our API that we set up before. And the score should give us a value back that makes sense. It's not giving us a value back, it makes sense. I'm wondering, sometimes, make sure that the params are empty, see if that helps. That's also not helping. I would like to show a functional output here so we can go look at things. I see we are out of time. Yeah, I don't know if there's any last second things, Jess or Madison, you want me to touch base on.
We are coming up to the end, but I think this gave us a really great technical overview of all the different aspects of the platform and how you map the ML canvas to what goes where in the Workbench. That was a great session. Thank you so much.